Shende from Tulsiramji Gaikwad Patil College of Engineering and Technology, Nagpur. Today, I am going to discuss about the second law of the thermodynamics. In this video, we will cover the statement of the second law of the thermodynamics, general statement of the second law of thermodynamics. Now, two type of the statement is given the second law of the thermodynamics. First one is the Kelvin-Planck statement and second one is the Clausius statement. And in this video, we will cover the thermal energy reservoir. It is an important term to understand the second law of the thermodynamics. Right? Now, moving towards the thermal energy reservoir. Thermal energy reservoir. What is a thermal energy reservoir? Now, look it here. This is the thermal energy reservoir. The thermal energy reservoir is nothing but it is a large amount of the heat capacity or infinite heat capacity is known as a thermal energy reservoir. Infinite heat capacity, right? फॉर एग्जाम्पल ले लो आप सन को ले लो या सी को ले लो. अगर सन से ऊर्जा आ रही है या फिर आप ऊर्जा उससे ले रहे हो या फिर सन को कोई ऊर्जा दे रहे हो, उसके टेम्परेचर पे कभी भी इफेक्ट नहीं पड़ेगा. नाउ सेकेंड एग्जाम्पल इज अ सी. अगर वहां से कोई वाटर निकाल लो, एक बाल्टी आपने वाटर निकाल लिया उसमें से या फिर एक बकेट आपने वाटर को उसमें डाल दिया, उसके टेम्परेचर पे कोई भी इफेक्ट नहीं पड़ेगा. ऐसी बॉडी को हम बोलेंगे थर्मल एनर्जी रिजर्वायर. सो इट इज अ इनफाइनाइट हीट कैपेसिटी. नाउ द एनी बॉडी in which whatever the amount of the heat will be supplied and whatever the heat will be rejected does not matter, there is a no significant change in the temperature of the body. The reservoir is known as a thermal energy reservoir. That's it. Now, there are the two type of the thermal energy reservoir. First one is a source. First one is the source and second one is the sink. Second one is a sink. Look at here. The body here, body what? This is a body. This is known as a source. The source temperature is, for example, T1. Source temperature is known as a T1. The source is nothing but it is the supplier of the heat energy without affecting its temperature. It is only supplier of the heat energy. Here, only supplier of the heat energy without any affecting on its the temperature is known as a source. First diagram. Now, second diagram is here, sink. The sink is nothing but it is the absorber of the heat energy without any change in its temperature is known as a sink. Look at here, only absorbing the heat energy without any affecting on its temperature is known as a sink. पहली चीज मैं बता चुका हूं कि इसके भी टेम्परेचर पे और इसके भी टेम्परेचर पे कोई भी चेंज नहीं होगा. दैट्स मीन्स नोट द इम्पोर्टेंट पॉइंट इज हियर. द बोथ बॉडी मीन्स सोर्स एंड सिंक आर द isothermal body because the temperature do not change. Now here the both body is a isothermal body. Both body is a isothermal body. Right? Source means the heat will be supplied without any affecting on its temperature. Sink means the heat will be absorbed without any affecting on its temperature. Now, moving towards the second law of the thermodynamics. What is the second law of the thermodynamics? I already talked about the heat and work. You know very well the heat and work. Both are the modes of the energy only. This is not a type of the energy. You know very well the heat is a low grade energy. The heat is a low grade energy. The heat is a low grade energy and work is a high grade energy. High grade energy. The first general statement of the second law of the thermodynamics is nothing but the complete conversion of the low grade energy into high grade energy is not possible. Is not possible. But high grade energy into low grade energy is completely possible. Here general statement of the second law of the thermodynamics. Now look at here the different statement of the second law of the thermodynamics. First, I want to discuss about the Kelvin-Planck statement. Kelvin-Planck statement. Sometimes the Kelvin name is the Thomson. Thomson. Here, the Thomson-Planck statement also. Thomson-Planck statement. Right? Sometimes called the KP statement. Kelvin-Planck statement. Right? Now, the Kelvin-Planck statement is state that it is impossible to construct a device or machine which can produce any continuous work by taking the heat from a single thermal energy reservoir. Meant, look at here. Here, single thermal energy reservoir. The heat will be supplied. For example, Q will be supplied in this device or machine. Here, temperature is a T1. Now, it is impossible to construct a device. It is impossible to construct a device which can produce the continuous work. Which can produce the continuous work by taking only single thermal reservoir. By taking the heat from the single thermal reservoir. Right? तो अगर यहाँ पे एक ही थर्मल रिजर्वायर होगा जो कि हीट जितनी दे रहे इस डिवाइस को ये पूरा का पूरा वर्क में कन्वर्ट कर जाएगा, तो ऐसा कभी भी पॉसिबल नहीं है. एंड दिस लॉ इज गिवन बाय द प्लांक्स लॉ या केल्विन-प्लांक्स लॉ. राइट? इट इज इम्पॉसिबल टू कंस्ट्रक्ट अ डिवाइस व्हिच कैन प्रोड्यूस द continuous work by taking the heat from only single thermal energy reservoir, and this type of the device is known as a PMM2, perpetual motion machine of the second kind. Right? In the case of the perpetual motion machine of the second kind, it is impossible to construct a device which can produce the continuous work by taking the heat from only single thermal energy reservoir. Right? I want to discuss about the efficiency of the PMM2. Look at here, the PMM1, efficiency of the PMM2. Here, the input over the output. यहाँ पे हमने इनपुट क्या दिया? तो हमने इनपुट दिया हीट की सप्लाई की. Which one? This is a Q. And here हमें जो आउटपुट मिला वो क्या मिला? W. W is out. But in this case, in this device, जितनी हमें हीट यहाँ पे सप्लाई की थी पूरी की पूरी हमने वर्क में कन्वर्ट कर ली थी in the case of the PMM2. So I can write the efficiency of the PMM2 is equal to W over the W, that means 1. Here the efficiency of the PMM2 is equal to the 100%, जो कि possible नहीं है. So it is impossible to construct a device which can produce the continuous work, it having only heat from single thermal energy reservoir. That's it. This is the statement of the Kelvin-Planck statement. Now moving towards the next statement is Clausius statement. Clausius statement. In case of the Clausius statement, the Clausius statement is state that it is impossible to construct a device or machine which can transfer the heat from lower temperature to higher temperature, lower temperature to higher temperature without any external input is known as a Clausius statement given by. ऐसी मशीन बनाना इम्पॉसिबल है जो कि हायर टेम्परेचर से लोअर टेम्परेचर तो चले जाएगा, बट लोअर टेम्परेचर से हाई टेम्परेचर अगर कोई हम वर्क करेंगे तो ही होगा, अदरवाइज बिना कि कोई वर्क किए हुए हाई टेम्परेचर से लोअर टेम्परेचर तो चला जाएगा, बट लोअर टेम्परेचर से हाई टेम्परेचर अगर करना है तो कोई ना कोई वहाँ पे वर्क देना पड़ेगा. ये स्टेटमेंट किसने दिया था? ये स्टेटमेंट दिया था क्लासियस ने. लुक एट हियर the one reservoir, here any device, this one is another device, this is the source, here temperature is T1 and here temperature is T2. Okay? It is impossible to construct a device or machine, it is impossible to construct a device or machine which can transfer the heat from lower temperature to the high temperature. Here this is the high temperature and this one is the lower temperature. For example, the heat is from lower temperature to the higher temperature. It is not possible without any work produced. जब कोई वर्क नहीं दोगे इस मशीन को या इस डिवाइस को, तब तक आप लोअर टेम्परेचर से हाई टेम्परेचर तक नहीं लेके जा सकते. यही बोला था किसने? क्लासियस ने. राइट, अंडरस्टूड? दिस इज द बेसिक concept of the Kelvin-Planck statement and Clausius statement. Now, in the next lecture, we want to discuss about the introductory part of the Kelvin-Planck statement and the Clausius statement. Thank you.